Hey everyone, so here I'm doing a rationalize the denominator topic. It's really important. So let's take a small example to understand what we mean by rationalizing the denominator. So here, let me take an example, a small example. Suppose I have 3 upon root 5. Okay, now what happens is whenever we have a root, it could be a square root or cube root in the denominator, then it becomes very difficult to solve this. It's not a problem in having an irrational number or a square root or cube root in the denominator, but to solve further it becomes very complicated. So here we're going to make this irrational number or the root into rational form. That is, we're going to change the denominator to the rational number, and that method is called as rationalizing the denominator. But how to do it? So what I'm going to do, whatever number I have in a root, here only root 5 is in a root, it's a 5 is under the root, so I'm going to multiply root 5 in both numerator and denominator. That is, so this will be equal to 3 upon root 5. Okay, I'm going to multiply both numerator and denominator. So here root 5 upon root 5. Okay, so I'm going to multiply the numerators and denominator. So 3 into root 5 is nothing but 3 root 5. Yes, and root 5 into root 5 will be just simplify. I guess you might have learned that whenever you're multiplying the same root, the root will be removed, only number will be left. So here root 5 into root 5 is nothing but just simplify. Okay, so we got 5 here. So you can see that in the denominator I got the rational number. Yes, so it's okay if we have a root in the numerator, that's fine. In denominator I got 5. So this is called as rationalizing the denominator, or how to rationalize it. Now I'll take one more example. Suppose I have like 3 upon 2 root 5. Okay, now you might be thinking with what we should multiply. So here you don't have to multiply with 2 because 2 is already a rational number. We want to only remove this root 5. In that case you multiply root 5 in the numerator and denominator. That's it. So this will be like 3 root 5 upon, so 5 into root 5 will be 5, and we have a 2 also, so it become 2 into 5, which is nothing but 10. So answer will be 3 root 5 upon 10. Okay, I hope it's clear. This was small example. Let us take one more example. Now here I'm gonna take 2 terms in the denominator. Means suppose I have, let me take 2 upon, here I'll take 3 plus root 5, or let me take 3 minus root 5, that will be better. So 3 minus root 5. Now if you observe here I have 2 terms, then how to solve this one? It's very simple. You have to multiply with the conjugate, multiply numerator and denominator with conjugate of the denominator. So in denominator I have 3 minus root 5, so its conjugate will be nothing but, we'll get same terms 3 and root 5, but negative will become positive. So conjugate of 3 minus root 5 will be nothing but 3 plus root 5. Similarly, suppose I have a root 2 plus root 7, so its conjugate will be nothing but root 2 minus root 7. So it's very simple. Whatever sign you have, just change that. Plus will become minus, minus will become plus. That's it. And then you have to multiply both numerator and denominator with that. So here if I multiply, let's see what I will get. So I'm going to multiply both numerator and denominator with a conjugate. So 3 minus root 5 multiplied by here 3 plus root 5, and here we'll get 3 plus root 5. We're multiplying both numerator and denominator with 3 plus root 5. Now we're going to multiply the numerators here. So this will be equal to 2 into 3 plus root 5. Now if you look at the denominator, let's see what happens. This is like a minus b into a plus b. I hope you remember this identity a plus b into a minus b. So a minus b or a plus b, you can just write anyway. So this will be equal to a square minus b square. I hope you remember this identity. I'm gonna apply this identity to solve this. So it's like, in place of a I have 3, in place of b I have a root 5. That's it. Substitute here a square minus b square. So a square will be 3 square minus b is root 5 minus root 5 square. So it's very simple. We're applying identity to solve the denominator part. So this will be equal to, you can open the bracket in the numerator, you can just leave it like that. If I open, I'll get 2 into 3 6 plus 2 into root 5 will be 2 root 5 upon, so 3 square is 9 minus root 5 square. Root 5 square is nothing but root 5 into root 5, which is nothing but 5. So we'll get here 5, and this is equal to 6 plus 2 root 5 upon 9 minus 5 is 4. So you can see that in denominator we got rational number. So it's very simple. If we have a 2 terms in denominator, you have to multiply numerator and denominator with a conjugate. Now what is conjugate? Whatever you have in the denominator, just simply change the sign. That's it. The sign which is present between the 2 terms, you have to just change it and apply this identity. Every time you have to apply this identity to solve the denominator. Okay, you can open the brackets and solve, but it's simply, if you apply this identity, it will become much easier. Let me take a small example and then we are done. So here I've taken 2 terms in the numerator. So root 3 plus 2 upon root 2 plus root 3. How to solve this? So the very first step, multiply the numerator and denominator with the conjugate. So conjugate will be nothing but root 2 minus root 3, because we have plus sign here, so it will become minus. So this will be equal to root 3 plus 2 upon root 2 plus root 3. I'm going to multiply the numerator with root 2 minus root 3. This is a conjugate upon root 2 minus root 3. So I have 2 terms in the numerator, right? So it will become root 3 plus 2 into root 2 minus root 3 upon, here in denominator, this is like again a plus b into a minus b. So we know a plus b into a minus b is nothing but a square minus b square. We have just applied. So in place of a I have a root 2, in place of b I have a root 3. So this will become root 2 square minus root 3 square. Okay. Now in the numerator we cannot apply any identity. We have to open the bracket and solve. So when you open the bracket and solve, you have to multiply root 3 with the entire bracket and then root 2 with the entire that second bracket. So this will be equal to root 3 into root 2 minus root 3, and then we have a plus sign here, so put plus, then 2 into root 2 minus root 3 upon, so here we have a root 2 square. So root 2 square is nothing but root 2 into root 2. So root 2 into root 2 will be nothing but 2. Okay, so this will become 2 minus, again root 3 square is nothing but root 3 into root 3, which is nothing but simply 3. So we'll get here 3. Now we'll open the brackets in the numerator. So root 3 into root 2 will become root 6. You have to just multiply the numbers inside the root, minus root 3 into root 3 will become 3, plus 2 into root 2 will become 2 root 2. We cannot multiply 2 and 2 because root 2 is irrational, 2 is a rational. We cannot multiply them. Then minus 2 into root 3 will be 2 root 3. Okay, upon 2 minus 3 is minus 1. Now we're going to solve the like terms here. So if you see we don't have any like terms in the numerator, So it will become root 6 minus 3 plus 2 root 2 minus 2 root 3 upon minus 1. That's it. We cannot solve further. So this is how it goes. I hope it's clear. So in case you have any questions or doubts, you can drop a comment below. Thank you so much for watching.